Hey everyone, so welcome back to the P3 series. So today we're going to start talking about integration. So integration is a longer topic, so we will split this in 2-3 videos. So the first thing that we have to learn or relearn in integration is that integration is the reverse of differentiation. So recalling the general forms of the few functions that we studied in differentiation, easiest one to recall is the exponential function where the power is some function of x. So the general form of the derivative was that we will have the same function back, but multiplied by the derivative. Since integration is the reverse of differentiation, the reverse chain rule would apply also. So integral of e raised to power g of x dx would have us same thing, e raised to power gx, but divided by the derivative of the power, n plus c. Similarly, we had the ln function, ln of some function. We had general form was g prime of x divided by g of x. So that means when we are encountering such a form where we have a fraction, rational expression on numerator, rational expression on denominator, and we can identify that the numerator is the derivative of the denominator, or we can somehow manipulate that, we will get ln of g of x. This mod operator is to make sure that we have a positive thing. Similarly, we had sine, cos, and tan. So derivative of sine of some function, we get cos of g of x, and times by the derivative of g of x. So we are going to have the same thing backwards for integration. So that means if I have integral of cos of some function of x inside, whether it's a linear function or nonlinear function, the way to handle it would be the same. We would turn it back into sine. So the integral of cosine is sine, as we remember from P1. No, sorry, not P1. Sorry, my bad. Integral of cosine would be sine. Same angle as before, divided by the derivative of the angle plus c. So similarly, let's see the cosine. Derivative of cosine of some g of x. This was minus sine g of x, but times by the derivative of the angle. Over here, we would have the same thing. So integral of sine g of x, that will get us minus cos, same angle, back again, but divided by g prime. So this is an application of the reverse chain rule, basically. So on the left side, we found these general formulae or general forms using the chain rule. The right side is the reverse use of that. So without having to uh, go through the process of deriving these, we can memorize these general forms easily. Similarly, we have tan also. Tan of some function of x Oh, sorry. Yeah, okay. The derivative of tan, we remember that was secant squared, same function, but multiplied by the derivative of the angle. Same way, integral of secant squared g of x dx would be tan of same angle, but with divided by the derivative of the angle plus c. For the integral of tan, we have to employ a different process. So we'll come back to that. Similarly, for the integration of ln function, we have to use integration by parts. So again, we will explore that in that particular video. Now, similarly, just like tan, we had talked about the tan inverse also. So if you remember the general form of the tan inverse, so tan inverse of ax, that's what we did differentiation. It comes out to be a over 1 plus a squared x squared. So that means if we get the same integral back again, we can transform it into tan inverse. So for example, that means we don't always have a over here. So what we can do over here, so if we get 1 over 1 plus a squared x squared dx, we can, to make it into a over that form, we can multiply by a and divide by a over here. So now this can become 1 over a, which is from the pink outside, and this simply becomes tan inverse of ax plus c. So basically what you have to see over here, whatever is being multiplied over here comes as a square root over here. Now, the students often get stuck with this one, so let's take a few examples these. This one first, and then we'll talk about the rest. So for example, let's say you have integral of 1 over 1 plus 4x squared. This is very straightforward. We have 1 plus something. This thing, the coefficient of x squared, is already a square. So this just simply becomes, see, we need the square root of 4 on the top and outside. So now we can rewrite it as 1 over 2 tan inverse of whatever this is, square root 2x plus c. Similarly, what if instead of 1 we have something else? So let's say you have 3 plus 4x squared dx. So this time we can't just have same thing. We need to make this 3 into 1. So what we do is we factorize out the 3. By doing this, simply 1 plus 4 over 3 x squared. Now the square root of this 4 over 3 is going to be multiplied and divided. So 2 over root 3, and since we are dividing it outside, so 1 divided by 2 over square root 3. So this actually becomes root 3 over 2 tan, oh sorry, we have this this 3 also. So times by 3 tan inverse of square root of this thing, 2 over root 3x plus c. So the final answer can be simplified as root 3 over 6 tan inverse of 2 over root 3. So basically you can rationalize that also. So that would become 2 root 3 over 3x plus c. Similarly, up over here, we had this form also, which is kind of tricky, the derivative over here. So let's talk about this also before we do any questions. So the ln form suggests that we have the derivative of a function which is in the denominator. So derivative on the numerator, function itself on the denominator. So examples, for example, you could have 1 over x, you could have 1 over x plus 3, for example, a linear function. You could have, for example, x over x squared plus 3. Although x is not the derivative, but it's in that particular form. All right. Similarly, sine over cos or cos over tan, cos over sine is also in a similar fashion over here. So not strictly the derivatives over here, but in the same form. So let's see how we can actually deal with them. So let's say we have the first example, integral of 1 over x dx, which is, we know this by heart now. The derivative of ln x is 1 over x, so this would be ln x plus c. For the second one, you have 1 over x plus 3 dx. This would just simply become ln x plus 3 plus c. Similarly, you have integral of x over x squared plus 3 dx. Now, x is not strictly the derivative. To make it into a derivative, we multiply by 2, divide by 2, and this simply becomes 1 over 2 ln x squared plus 3 plus c. Now, sine over cos, tan, is a very interesting example, and we deal with it the same particular way. So integral of tan x dx, which is basically sine x cos x dx. Now, the derivative of cosine is minus sine x, not positive. So we multiply by minus 1 and minus 1. So now we can do that. So minus ln cos x plus c. Since this is minus ln, we can rewrite it as ln of secant x plus c also. Similarly, you could have a similar process for cotangent also. It's a very simple procedure over here. So all you need is the derivative on the numerator, and you can handle that. So kind of reciprocal functions, uh, like the first and the two, we often encounter these in partial fraction questions. So that's where we will need them. So let's talk about the kind of questions that you will see in the exam, and most of them will be in the partial fraction form. Then you will expand into partial fractions, and you will have to deal with either some form of this type of fractions and some form of this type of fractions, or sorry, in this type of where you have to do the tan inverse. So all right, let's see a few questions as an example. All right, so let's see this. Now, this question does not require partial fractions at the face value. So if you notice, you have power x squared, order of polynomial is x squared, you have x squared. So rather than doing partial fractions first, we have to do the long division first to split it. So what we do over here, we do the long division. So this is x squared plus x over x squared plus 4. So first off, we need to do the long division. So x squared plus x plus 0, and we have x squared plus 4. So once we do 1, we get x squared plus 4. So minus minus, you get simply x minus 4. So this can be written as 1 plus x minus 4 over x squared plus 4. Now, to further split this down, this is where we will have to do the partial fractions now. So now we split this thing, x minus 4 over x squared plus 4. Actually, we don't even need the partial fractions. We can just simply do it like this, x plus 4 minus 4 over x squared plus 4. So the full thing entirely, x plus 1, x squared plus 4 dx from 0 to 6 can be split into 1 plus x over x squared plus 4 minus 4 over x squared plus 4 dx from 0 to 6. Now, this is very easy now. So the integral of 1 would be just simply x. The second fraction, if you notice, the derivative, the form of the derivative is on the numerator, not strictly the derivative itself. The derivative would have been 2x. To deal with this, we multiply by 1 over 2 over here. So we will get 1 over 2 ln x squared plus 4. However, in the third one, there is no derivative. It's just a constant over here. So we have to deal with this using the tan problem. So let's deal with this separately. So 4 over 1 over x squared plus 4 dx. We want it in 1 plus something form. So 4, 1 plus x squared over 4 dx. And what we just simply need in the numerator is the square root of this 1 over 4. So 1 over 2 over here, 1 over 2 over here. So we will get 8 over 4 because you have this 4 also, basically. So times by tan inverse of 1 over 2x, simply. So 8 over 4 is 2, tan inverse of 1 over 2x, and finally now we plug in the limits. So limits would be 6 plus 1 over 2, 36 plus 4 is 40. So ln 40 minus 2 tan inverse of 6 over 2, 3x. Sorry, 6 over 2 would be just 3. Minus 0 plus half ln 4 and minus 2 tan inverse of 0. So let's find the exact answer. So half ln 40, we can split 40 into 4 and 10 over here. So we have 6 minus 0 plus half ln 4 plus half ln 10. minus 2 tan inverse of 3. We have, first let's deal with the half ln 4 also. So minus half ln 4 and minus minus plus 2, minus 2 tan inverse of 3 and plus 2 tan inverse of 0. So 6 minus 0 is just 6. Half ln 4 cancels out with half ln 4. Half ln 10 just simply remains that. So half ln 10. And 2 tan inverse of 3, we can keep it that way because this is the exact value. So 2 minus 2 tan inverse of 3. And tan inverse of 0 is 0. So this is the exact form. All right, so let's see another question. All right, so let's see another question. Similar thing. So let f of x is this, express f of x in partial fractions, and then b part is find the integral. So this is a very common question that comes up occasionally. So first off, we need to do the partial fraction. So although we did this in the partial fractions topic, I think we can probably find that. Yeah, so we did this. I'll put a link over here for the partial fractions video. We did this question. So 2x plus 1, x plus 2 whole square. So we have 1 over 2x plus 1 minus 2 over x plus 2 and plus 3 over x plus 2 whole square. So that means the integral of this thing is basically the integral of this thing. So for the first one, to find the integral, we need to, okay, let's separate it for one time so that I can show you. So 1 over 2x plus 1 dx minus 2 over x plus 2. Actually, we don't need the 2 over here. We can write the 2 over here. Dx plus 3 over, this thing can be written as x plus 2 minus 2 dx. So for the first one, we need the derivative on the numerator, so multiplied by 2 divided by 2. So this becomes half ln 2x plus 1 minus 2. The derivative is already in the numerator, so 2 ln x plus 2 plus 3 integral. We have power over here. So first we increase the power, divide by that. So x plus 2 minus 1 divided by minus 1. And then let's not forget the chain rule. We will also have to multiply by the derivative. We also have to divide by the derivative of x plus 2, which is 1 over here. And now the powers 0 to 4. So if I write this a little bit neatly over here, so this is half ln 2x plus 1 minus 2 ln x plus 2 plus, this will become minus 3 then. So minus 3 over x plus 2, 0 to 4. So now let's plug in the limits. So we have half ln 2 times by 4 is 8. 8 plus 1 is 9. Minus 2 ln 4 plus 2 is 6. Minus 3 over 6. whole minus half ln 2 times by 0 plus 1, so ln 1 minus 2 ln 2 and 3 over 2. So half ln 9 is basically just ln 3. 2 ln 6 is ln 36 minus 1 over 2 minus ln 1 is 0 minus 2 ln 2 is ln 4 and minus plus is 3 over 2. So 3 over 2 minus half, basically 1.5 minus half, 0.5 is just basically 1. And then we have ln 3, 4 in this. So we have ln 3, 4 over 36. So this becomes 1 over 1 plus ln 12 over 36, which is basically just 3. So this becomes 1 minus ln 3. So this is our final answer. All right, so let's see this question also. For the A part, we have done this in the partial fractions video. So I'll just simply rewrite this as 2x squared plus 17x minus 17. I'll put a link over this video for this if you want to go back and see. So that would be, sorry, minus 4 over 1 plus 2x minus 3 over 2 minus x and plus 5 over 2 minus x whole square. All right, so that means the integral of that f of x would be similar to integrating this. So in the b part, we are integrating, let's separate all of them. So 5 over 2 minus x whole squared separately, minus integral of 3 2 minus x dx separately, and minus 4 over 1 plus 2x separately. So this would be easy, first one. So 5 times by, times by the power on the 2 minus x is increased by 1, divided by that, and we multiply by the derivative of 2 minus x in the denominator, which is also minus 1. Minus, we don't need that. 3 is not the derivative of 2 minus x. So for that, we multiply an extra minus and minus with this. So outside it becomes plus 3 ln 2 minus x. Similarly, on the over here for the third one, it's very easy. 4 has nothing to do. So the derivative of 1 plus 2x would be 2. So multiplied by 2 divided by 2. So 4 divided by 2, and that would be ln 1 plus 2x from 0 to 1. 0 to 1, 0 to 1, 0 to 1. So this will become 5 over 2 minus x simply plus 3 ln 2 minus x minus 2 ln 1 plus 2x from 0 to 1. Now let's solve for the limits. So solve the limits. So 5 over 2 minus 1, which is just 5, 3 ln 2 minus 1 minus 2 ln 1 plus 2 minus 5 over 2 minus 0 plus 3 ln 2 minus 2 ln 1. So let's simplify. This would be just 5 plus 3 ln 2 minus 1 would be just 0 because ln 1 is 0 minus 2 ln 3 minus 5 over 2 minus 3 ln 2 and plus 0 because ln 1 is 0. So 5 minus 5 over 2 is basically just 5 over 2 itself. But minus 2 ln 3 can be written as ln of 9 and 3 ln 2 can be written as ln of 8. So this could further be written as 5 over 2 minus ln of 72. So why? Because you can write it like this. So 9 times by 8 is 72. And that's exactly what we have over here. All right. So let's see one more question from the March 2023. All right. So let's see this question also. Again, I will put a link over this. We did this question in the partial fractions video. So this f of x can be split into 3 over 1 plus x and plus 2x minus 1, 4 plus x squared. So, all right. Although this was the partial fractions, for integration, we would need just a little bit one more step. So f of x can be written as 3 over 1 plus x plus we can split this into 2x over x squared plus 4 and minus 1 over 4 plus x squared. Now I think it should be clear why we did that, because we are integrating this dx, dx, dx from 0 to 2, 0 to 2, 0 to 2, 0 to 2. Now we integrate. This just simply becomes, the first one just simply becomes 3 ln 1 plus x. The second one, the derivative is already on the numerator, so we don't have to do anything even. So ln x squared plus 4. For the second one, it's the tan form over here. So for the tan form, now you can memorize the general form also. However, you can do the little bit of practice. This will help you in remembering what to do over here. So first 4 comes out. This becomes 1 over 1 plus x squared over 4. So to make it into tan form, we need to multiply and divide by the square root of 1 over 4. So which is 1 over 2 over here and 1 over 2 over here. So this one just becomes 1 over 2 tan inverse of 1 over 2 x plus c. So you will have 1 over 2 tan inverse of 1 over 2x from 0 to 2. So this would be 3 ln 1 plus 2, 3 plus ln 2 squared is 4, 4 plus 4, 8 minus half tan inverse of 2 over 2 1 minus 3 ln 1 plus 0 is just 1 plus ln 4 minus half tan inverse of 0. So 3 ln 3 plus ln 8. So this just simply becomes 27 times by 8. So first let's write it. 27 plus ln 8 minus tan inverse of 1 is pi by 4. So half pi by 4 minus 3 ln 1 is just simply 0. Ln 4 and also 0 because tan inverse is 0. So collecting all the ln terms together, you have 27 times by 8. Wait, sorry, this was minus. This was minus, and this would have been plus. So over 4 minus half of pi by 4 is pi by 8. So 4 times by 2 and 27 times by 2 is 56. So ln of 56 minus pi by 8. Oh, sorry, no, 54, sorry, 54, 54 minus pi by 8. And that's exactly what we have over here. Yes, that's exactly what we have over here. All right, so this is one line of questioning that is often asked. So if we had done the partial fractions also, it would have taken a lot of time. So thankfully, we had done these in a different video. Now, in the next video, we'll talk about the products, how to deal with the products. So there are two ways we deal with the products, with substitution and with integration by parts. All right, so see you in the next video. Bye-bye.